Measure airflow cubic feet per minute with the heating, ventilation, and air conditioning temperature rise formula the right way by controlling leakage paths, shielding the blower motor compartment, and translating temperature rise and heat input into accurate cubic feet per minute numbers without guesswork. Start by confirming the furnace or air handler heat input is correct. Clock the gas meter for natural gas, or verify nameplate electrical heat kilowatts for electric heat, then adjust for elevation and gas heating value if needed. Without accurate heat input, your cubic feet per minute will be off. Use the formula cubic feet per minute equals output British thermal units per hour divided by 1.08 times temperature rise, where output British thermal units per hour equals input British thermal units per hour times steady state efficiency for gas heat, or equals 3,441 times kilowatts for electric heat. Stabilize the system at heating capacity for at least 10 to 15 minutes before measuring temperature rise to avoid transient readings. Measure supply air temperature and return air temperature with fast response thermistors or thermocouples placed away from heat exchangers, coils, or radiant surfaces. Average multiple points across the airstream to capture mixed air. Shield the blower motor compartment during testing with a tight cover so the blower does not pull room air, which artificially lowers temperature rise and inflates calculated cubic feet per minute. Use cardboard, sheet metal, tape, and magnets to make it airtight. Verify filter condition, coil cleanliness, and that all supply and return dampers are set as during normal operation, because changes in external static pressure directly change airflow. Record total external static pressure with a manometer and compare to the blower performance table to cross-check your formula-based cubic feet per minute. They should be in the same ballpark. If you need to target a specific airflow for heating or cooling, adjust blower tap or variable speed settings, then remeasure temperature rise and static pressure to confirm the new cubic feet per minute, and that temperature rise remains within manufacturer specs. One of the biggest heating, ventilation, and air conditioning airflow testing mistakes is failing to seal the blower motor compartment, which causes return air bypass, lower measured temperature rise, and a falsely high calculated cubic feet per minute. Fix it by covering the compartment tightly with rigid cardboard or sheet metal, sealing edges with foil tape, and using magnets to clamp the cover during the test. One of the most common temperature rise errors is taking supply and return temperatures in the wrong locations, such as too close to the heat exchanger or in the return drop near infiltration points. Fix it by measuring in the main supply trunk downstream of coil or plenum, and in the return plenum upstream of the filter, then averaging multiple traverse points. One of the frequent airflow calculation pitfalls is using input British thermal units per hour instead of output or ignoring steady state efficiency, which overstates airflow. Fix it by calculating output British thermal units per hour from measured input multiplied by measured or rated efficiency, or by using electric strip heat where output is straightforward. Then compute cubic feet per minute as output divided by 1.08 times temperature rise. BigHomeProjects.com connects homeowners with vetted heating, ventilation, and air conditioning contractors who understand airflow testing, temperature rise measurement, blower compartment sealing, and accurate cubic feet per minute verification. Contractors use BigHomeProjects.com to showcase qualifications, earn reviews, and win more work, while homeowners get fast access to trusted local pros for furnace diagnostics, airflow balancing, and energy-efficient system tune-ups.